When we look at the sky at night, we see all the stars move from east to west, each forming a perfect circle. As in circular motion, its velocity and acceleration would be constant. So does our sun during the day as it moves along the ecliptic. There is no way not to notice the influence of the observer, who feels as if he were in the center of a whirlpool. We are the ones who relay the planet's movement to the sun and the other stars, as they remain relatively motionless in the celestial vault. There is also no way not to distrust the light we use to describe the circular motion of the stars, since the actual movement of the Earth around the Sun forms an ellipse over time, and not a circle. Unlike the elliptical movement, in the circular one there are no cyclic movements of approaching or moving away. It is as if this type of movement describes a state of rest and static equilibrium. Someone is missing the truth. If you stop looking at the stars and concentrated on observing atomic structure, you would find that the picture is exactly the same. The electrons appear to revolve around the nucleus of the atom with constant speed and acceleration. Due to the immense difference between the masses of the electrons and that of the nucleus, the center of mass remains close to the latter. Therefore, science considers that the nucleus remains immobile on the center, while the other subatomic particles revolve around it in a circular motion. The immediate conclusion is drawn from a common point. Both the observation of the celestial vault and that of the microstructure depend on the light that the particles emit or reflect. The problem is in the observer. But this is an advantage. Observation allows us to unify these two extremes of matter. The problems that had elliptical motion and presented as being circular and uniform were identical in the micro and macrostructure of the universe. How could this riddle be solved? The author's suggestion is that we look for the causes in the one who would be responsible for delivering the information, leaving everything else aside. See well. In order to see a particle, such as an electron, we first need to illuminate it. The electron is, then, seen with a fraction of a delay. Light is also what allows us to see a distant star. Although the delay in communicating the existence of a star is apparently much greater, this waiting time disappears in practice and equals that of the electron. Infinities become equal at all levels of matter when it comes to observation. A strong indication of what has been said is that we need starlight to have already reached us. Otherwise, the star could not be seen in the night sky. This shift from the 0 point of time, from the position of the stars to our position on Earth, is real to us, even if it doesn't fit in with physical reality. The light would act like a messenger. With that, space would lose its power of communication, becoming dependent on light. This explains the delay and the impossibility of seeing the particles in real time. This is because, according to quantum mechanics, the light used to illuminate a particle disturbs its position or speed in an unavoidable way. This generates an uncertainty principle. If we were to unite all the structures of matter at the level of observation, the uncertainty would also need to be valid for the case of stars. In fact, when a star could be seen, after many years, by the light it would have emitted, this light would describe a virtual point in space, which would have been occupied by the star in the past. When that happened, the star would already be occupying an uncertain point in space. It may even have exploded and become a supernova, but it would continue to shine normally until the hypothetical event was communicated to Earth. It it is possible that the relative motion we observe in the night sky is the responsibility of the messenger from space. Science attests to this when it tells us that there is no absolute movement. This is tricky, as it suggests that the universe was static in origin. It seems that we depend on the messenger to access information about delayed relative motion, an event associated with position or velocity uncertainty. If the primary universe, from which light emanates, were static, we would have to be expelled from there in order to be able to see it with delay. Thus, time would be separating us from reality. But time is all the makings of an illusion. The delay that prevents us from seeing a star instantly cannot be directly measured. Thus, due to the laziness of the messenger, the future is confused with the present. It's just that you would be looking at the present with a delay, which generates another illusion that of time in the past. See the confusion? The past is no more, and the future has not yet arrived. In the case of the present, it's always slipping away, because you have to think about what it would be. Consulting the files in your memory takes time. Thus, when you come to a conclusion about the present, you will already be looking at your own past. The behavior of the messenger from space could explain what happens at the subatomic level, since when it comes to observation, it doesn't matter what level of matter is considered. All sorts of matter would similarly depend on remote tracking of light to reveal their existence. Thus, what happened in the macrostructure would have to be valid for the level of atoms. Those who follow the author's videos are already tired of hearing about the model of the mass spring set and the harmonic behavior of light. But there is no way to avoid saying that the phases of the harmonic movement would be mutually exclusive. There are numerous indications that, when astronomers try to think about the behavior of space, they are actually talking about the behavior of light or cosmic radiation. We have no other tool to describe the geometry of space. Space bends because light bends. Otherwise, we would not be able to demonstrate the change in its geometry. So, from here on, let's talk about space and light, as if they were both one and the same thing. The first phase of the harmonic motion of light would coincide with the stretching phase of space. The light would shift towards red, and space would follow this polarization of light, stretching and increasing its curvature. In this phase, there would be a predominance of potential energy over kinetic energy. The force would point in the opposite direction to the stretch. If the curvature of space, or its depth, were considered the third dimension, it would tend to disappear, and space would tend to return to its two original dimensions, width and length. As the depth of space is indelibly associated with time, it is said that, in the first phase of the messenger's harmonic movement, time should contract and tend to zero. Thus, even if the light were polarized in this phase, it would be retained, waiting for there to be an inversion in the direction of the arrow of time, and for time to be able to dilate. This would be the characteristic of the second phase of harmonic motion. It would allow us to describe acceleration and motion with delay. The spring, which was previously at rest at infinity, would already appear contracting, with the potential energy always decreasing. This is the main feature of our light observable universe. In summary, it can be said that the continuous dilation of time is what allows us to see, instantly but with delay, the polarization of light, characteristic of the previous phase. The polarization we see in the redshift is not real, as the line would describe a frame before the Big Bang. When we see the polarization of light, it should already be depolarizing. To visualize, think of the depth of a cone, an image used to describe the curvature of space. If you were to undo this curvature in the first phase of the harmonic movement of light, by contracting time, you would be ending its polarization and flattening this cone over the two dimensions of space. After the inversion of the arrow of time, space seems to be gradually increasing its curvature. The most logical thing would be to expect the opposite, due to the depolarization of light in the second phase of its harmonic motion. As we are trying to unify the structures at the level of observation, the behavior of the electron would also be tied to that of light, which we use to describe its movement in space. Thus, the quantization of light, or its packaging, grows in importance, which will lead to the photon to be scattered by the particle. As we saw just before, the first phase of harmonic motion would be followed by the contraction of time. Without measurable time, there could be no movement. Both Geiger demonstrated that quantization would be a timeless process. When a quantum collides with a free electron, both appear simultaneously. Borrowing the behavior of light in the macrostructure of the universe, it is seen that when the electron disappeared at the minimum energy level, the light that we use to describe its movement would have entered its timeless quantization phase. Therefore, it could not be found anywhere between atomic levels. As there would be no time involved in this light packing process, the illuminated electron would appear to be in two places at the same time, simultaneously at the level of maximum and minimum energy. What is the expected movement that should be assumed by the electron under these conditions? The answer, you already know, is circular motion. By similarity with the observation of the stars, it can be said that, in an atom, the potential energy of the particles would always be decreasing and never increasing. The spring of space would always be in its contraction phase, or in the second phase of the harmonic movement of light. Perhaps, this was behind the stability of the atomic structure. Who knows?